So the reason why we are doing this is because the AI strategic initiative has started in Q1 this year. We are working on two main legs. One is AI readiness SIG, so we are trying to find a way to help banks to onboard AI in their processes by building a governance framework, which we have released this morning if you were at the GAP's keynote. Next to the AI readiness SIG, we are also working on FINOS LLM exploration. And this workshop is one of these use cases happening at the FINOS LLM exploration. So what we are doing at FINOS LLM exploration, we are looking at use cases that are relevant for all FINOS, for most of FINOS members, where there are common challenges that can be solved in an open setting. We focus on use cases, so in order to start, we have to identify the use cases. And the way we identify use cases is we organize workshops. So we organized a workshop in London 2 months ago, just before OS Club London, and the community came up with some ideas of which use cases are really relevant for the community. So in the So one of the use cases was how to apply CDM documentation to LLM paradigms, and we understand that CDM is very important, right, for this community because it enables interoperability. It's also true that CDM is not really an easy standard for a newcomer. It's very extensive. There are different the documentation is extensive. So we understood that applying LLM paradigms to CDM was a really good use case. And that's why we are here today. So we've been working on this use case for 2 months with Tradeheader, Provectus, ISDA, and Columbia University. And today, we're going to show some prototypes of what can be done with LLMs applied to CDM. Any questions before we start the showcase? Right, so we can move on with the first work stream. And
thank you, Luca. This is very exciting. So thanks to Oleg and Peter there who are heckling me already. So I actually worked with Provectus for the last few weeks on this, and what we're going to do, do I just escape out of it? Or we're going to get to here, yeah. So what we did, and we can show you a diagram of the architecture in a minute if you're interested. But what we're going to start with is a chatbot, which we played around with and I tested and was very impressed by, because I wasn't really a buyer of the whole chatbot thing when I used it in my personal life, trying to use ChatGPT to do things. It was all a bit hallucinations and things and very strange behaviors. But because of the way this has been constructed by priming the model with, I'll try and not use model, priming the chatbot with data first from the CDM, from the documentation, and from the model itself, and then focusing the LLM to answer the question. It has pulled off some really amazing results. So, first up, I have a series of questions here that I've pre-run. But first up, what we're going to do is start with just some basic stuff that I think anyone would understand. Maybe I can zoom a bit, can I? There we go. That's better. Can you see that? You can see that a bit better. Okay. So, what is the CDM? Why should I care about it? How can I sell it internally and get resources to look at it and adopt it? If you do get those resources, where do I start? So it comes back with an answer, the benefits of the CDM, selling it internally, highlight the potential for operational efficiency improvements. It's kind of high-level stuff, but it's all coming from the documentation. It's pointing to how you get started and the resources for adoption. And there down the bottom we have the sources. So this is all just straight from the documentation. So the model has looked at the documentation and giving us pretty coherent and valid responses. Now that's baby steps, right? So what is the CDM? Sure, anyone could answer that question after all the events we've had or the sessions we've had on CDM. Starting developer questions. So again, focusing on a different part of the documentation, the key dependency, and just pointing to the repository for the Java versions there and Sonatype, and those links all work, but I won't click on them, and the GitHub page, and just telling a developer how you could get started with CDM, right? So the key bit that in our discussions with the group about where what I wanted to see as a kind of a CDM user was to get responses back that were very, very focused and technical and in the model, looking at the model rather than just the documentation, because documentation can be a bit vague. It's written as obviously in English. So we started to test it a bit more. Hang on, if I click that correctly. So where am I? Number 3. So here's some more detailed responses on a question. So I asked the question, I really don't understand the workflow structure, how state changes happen in the CDM across the workflow. How can I understand that? So the chatbot has come back with an explanation of the CDM workflow, very detailed, the workflow step structure, what's inside it, business event, proposed event, state changes, tells you how to do that. It's come back with some really, really powerful answers, but basically looking at the documentation again, but also it's starting to use as a source the source code itself, so the actual model. So then I asked it about the workflow step, can it fail or be rejected? And yeah, it's come back with specific code there from the model itself. So again, if we look at the sources, it's looking at specific areas of the model and looking at the GitHub pages, going in and looking at the actual source code. So powerful stuff. Now we got even deeper into it. Building payout examples. You all know what a payout is in CDM because you were at the talk yesterday, right? Anyway, I was interested to see if we could generate some real data, and because the potential for this then, if we could use the LLM to create real data, we can start to synthesize loads of test data, and we can do lots of exciting things. So I asked it to take a look at the model and then give me JSON examples of the payout object for a typical CDS trade. And it did a pretty good job. And here's the JSON coming out. It invented this company called Acme Corp. So it's obviously familiar with Looney Tunes cartoons, for those of you who know what I'm talking about. And it then filled in the various different types with the object values you can see there. And these are all correct and conforming with the CDM. So it's looked at the model. It's got created the JSON examples. It's summarized there. I think I asked it to summarize what's in there. It's got the credit default payout and the general terms, protection terms. This is all stuff straight out of the model. And there we have, at the bottom, its sources. So you can see that it used the documentation to give us the kind of the language around it, and then the specific source code it's used. Right. We go a bit further into it, and I know time is the essence. Where are we at with time?
You have 10 minutes.
Okay. Well, we'll look at another thing here. Okay. So the other side of the model. So we focused on the product model there. I was interested to then tack across the model. The model CDM covers products and events, but also legal data, and this is particularly useful for collateral use cases where we have we've modeled the credit support annexes and other related legal agreements, which are then used and govern behaviors and processes like exchanging collateral. You need to check these effectively documents that you've signed to tell you how much you can post or what you should post in terms of collateral. So I asked it a general question though. Can the CDM model legal agreements? Yes, it can. It gives some textual response there. How are they tied to the transaction? So this is in the contract details data type, which is at the top of the trade. You know, it gave us the instructions how that works, and there we have type contract details. And then what else did I do? Oh yeah, what does a legal agreement look like? Can you give me an example? Again, it was able to then give me back JSON objects that were correct. It's done a bit of, it's been a bit creative there with some dates. It's got English law. It's a credit support agreement. Now, interestingly, the model doesn't have some of this, some of these structures as we go further on. So it has a sort of a template for a legal agreement in the main CDM, but in another part that's in the ISDA foundations model, there's some further clauses which are defined. And it's created then, it's just filled in some flat JSON to sort of model these minimum transfer amount, rounding amount, which are typical, which are pretty close to what you do, but it's just left them in there as flat JSON in the body of the legal agreement. And it's come back and says we've added these agreement terms which are typical, which is quite creative and pretty helpful. Now, I have time to do the bonus complex task, which is really a really good one. So Shravan is here. He asked me a question a few weeks ago, which I was a little bit stumped by because I hadn't looked at the problem in a very long time. And we were looking at well, hang on, we were looking at affirmation as a process, and the affirmation process for matching and checking trades. And we hadn't, I couldn't recall, but the CDM was used to build an affirmation engine a few years ago. And at that time, maybe we didn't explore the functional elements of the process. It was really just we created the data types to store the affirmation data or to store the trade. So I asked the LLM, could it have a go at telling me how to upgrade the CDM to create an affirmation? And it went and found the affirmation type, which I mentioned did exist, and then it gave a proposed approach. And then it has the steps for changing it, so make a few changes to the type, and create a primitive instruction for affirmation instruction, and then create some specific functions for creating the affirmation. And like, it's pretty good. Like, I don't know, Dan's nodding his head positively. Maybe there might be a few tweaks, but it's pretty powerful stuff. And again, it's got the sources there. So that was a bonus question I wasn't hoping to get, or was going to avoid. But that's how far we got in a few weeks. Now, Oleg can probably talk about a bit of the background if you, or...
Yeah, no, happy to do that. We can maybe... Yeah, so I think those are the things that Ian just showed in terms of the workflow and what's involved here, right? So we looked at the chatbot, just that was the easiest and quick interface to build. This can be also done in a more user-friendly way, where there is a more interaction and the way we bring the data back. But on the background, there is a RAG, what we call advanced RAG approach, that was built to be able to bring the information from CDM. And when we talk about CDM, it's not only documentation. We brought documentation, we brought source code, and also Rosetta information there. And we updated on the back end. You can move to the next slide. It's all built on AWS infrastructure. you can see that we use Bedrock just to make sure that the information is secure and everything stays inside the container, doesn't leave the AWS. Not that it was really important for this particular project, but we wanted to show that in terms of the data governance, that was important to us. And then data lineage, you saw that when the results come back, you're able to point to the source that was used to generate that output, right? So those are the things that just wanted to cover. If there are any questions, I don't know if we have time, but happy to see if Ian or myself can answer. Yeah, so you actually can prompt to minimize that hallucination to pretty much non-exist. And I think that's what we were able to achieve here. We did change some of the parameters that were sent to LLM. I think we use Anthropic HiQ or Sonnet 3.5. I'm not sure exactly, can confirm that, but one of those LLMs. And we were able to, with specific prompts, to eliminate hallucination, at least in the use cases that we looked at. No, we have not done any training or any specific fine-tuning on this documentation or sources that were used here. The fine-tuning was done only on the parameters that were sent to LLM, right? So we fine-tuned that based on some of the responses, like temperature and some other things. But in terms of the fine-tuning, there was no specific training LLM on this particular data sources, if that was the question.
But this engineering on the prompt.
Yeah, the prompt was fine-tuned.
Yeah.
It's not a proprietary product. The intention was to show the capabilities of LLM, right? We used, in this particular case, Anthropic, but we can use any other open source LLM to fulfill the task.
So somebody sitting against the CDM repo is the ability to chat with it?
Maybe. There's just so many different ways. Like there's so many different possibilities. Like getting so close to be able to construct new code and model stuff to the functional level is pretty amazing. So as a kind of an autopilot, a helper could be great. Generating, synthesizing test data, just being able to get started in a way that suits the user. Jane, we were talking about different profiles of people and how you need to speak to people in different ways. Well, we can do that. So yeah, there's so many possibilities. But there's lots of other projects and examples we're going to see now. So I think there's so many different things we could do. I've been quite blown away by the experience. So. Yeah. So.
Thank you.
Thank you.
So I don't use a Mac, so I might mess up on the screens. So the research that we've been working on at ISDA this year was with CDM, which is the industry standard model for derivatives data. But it also, as Ian mentioned, has the model for credit support annexes. So CSAs are legal documents, and part of it is the master agreement. And if you've worked with legal documents at all, it makes my eye teary, not being in the legal realm. They're very complex, and sometimes, including with the ISDA master agreement, the pages can be over 100 pages. And there's references all over the legal document. The terms within the document itself aren't standard. So different organizations or even different lawyers might describe something differently when it should mean the same thing. So there's many different challenges with turning legacy CSAs into digitized format and putting it into a standard format for CDM. And the goal was for us, can we take a generative AI model and apply that model to extract the information from CSAs and turn them into CDM format without fine-tuning the information with a few shot prompting, one shot prompting. We have a lot more work to do, but the demo here for the POC is the initial version that we have. This is available, open source. I can give the link eventually. I think we'll provide it eventually, all these demos that we're giving. So earlier in the year, as part of our research into benchmarking all the different LLMs and looking into different methods to see which LLMs work the best, we've partnered up with AWS AI Cloud Innovation Center out of Arizona State University. And together, we've developed a framework for extracting terms, a scalable modular framework for extracting terms out of CSAs, and putting them into the CDM format, and that's what I'm going to be showing right now. So this is the architecture that we've come up with. It takes the multi-agent approach into an LLM design. So what this essentially shows is working with a multi-agent architecture. It's basically having many different agents, and in this case, agents that are designed to look for specific clauses. They're trained on, well, they're prompted on the few clauses that they have to concentrate on, and they'll go through them individually. At the top, what you see is the orchestration agent, which is the main, it's like the project manager. It oversees the entire process, and then it'll send out tasks to each of the clause agents, and then finally, it'll take the full CDM JSON representation that it's from the partial JSONs that are created by the individual agents. So the clause agents themselves are the actual experts in CDM clauses, let's say. So each of these experts are focusing on one or more clauses, and then within the agents themselves, we have a tailored prompt specifically for that agent, and then we have the CDM definition for that and examples for that clause within that agent. So all of that working together, they would, well, I guess the unique thing here is that each agent actually goes through the entire document. I mentioned before that these legal documents have references everywhere. So you can't necessarily have something like a RAG approach where you're looking up specific information and passing it to the agents. The agents looking for clauses has to go through the entire document to understand it. So with the narrow focus of these agents, they're going through each one of these agents are going through the document, looking for references all over the legal document and getting the information and then producing the JSON output for that particular clause. And then the final representation is done by the orchestration agent. Working with AWS, I think it's pretty obvious that we would build it on AWS. So we've built this on the Bedrock agent, but it's important to remember that the modular scalable approach that we've built here is easily replicated in an open source method. So it's important to know that it's the, I don't know how to go back on a Mac, so I won't, to note that the framework is there, but we've built the initial demo on AWS Bedrock. So within Bedrock itself, once you provide a file within S3 bucket, it's a file storage, the agent itself, the action groups functions are all part of the specific agents, will produce the partial JSON files, and then that's put together with the full CDM representation. And I'll show the demo next. Okay, so for the sake of time, Can I do it? I have to play it first before opening, right? I just created a video yesterday, just so I don't have to fiddle around with connecting to our environment. But this is the AWS Bedrock infrastructure, and this is the CDM generation agent that we've built. So going into this, I'll wait until we get into version 1. So here, what I wanted to show, this is one of the things with videos where I have to remember what I did. So with going into the view, this is what I wanted to show. The code itself is here. I'm gonna expand it. So pause it here. So the code itself, as you see here, each agent, this looks like this is the definition for the currency clause agent. So can you see it? What it shows is the initial prompts that are given to the agents themselves, saying what to look for, what some of the complexities are on the clause itself, and then below that is actually the definition provided by CDM. The idea behind this, right now, this information has been reworked and hard-coded into the code itself, but the idea behind this is eventually using a RAG system or knowledge graph system that Provectus demoed, and getting this information dynamically. So this information will always be up to date and relevant, and even if a LLM is fine-tuned on derivatives data, we would still get the most up-to-date CDM information. And then here, I show an example of a CSA. And this is the, Amy, you might correct me, but it's the 1994 CSA New York version. I can't expand it, sorry. So this is so I might actually go through, since nobody can see it, let's skip all this. But just scrolling down, you can see the length of the document. And what it showed was that some parts of the CSA had the actual clause, but then on the definition of that clause, it says, look at paragraph 13. So if you imagine a machine or traditional model trying to do this, it's got to be highly trained on that specific document. What we're trying to show with the generative AI model is that can we put this against any general CSA with its understanding of the legal framework, with the wording, can we put this with a few prompting techniques, put it against a legal document, have it understand any version of CSAs, any customizations that have been made to the CSAs, and have it produce the output that we want. This framework was designed specifically for the CSA model that's in CDM itself.
Which is would be 100%.
So, okay, then we get 100%. But let's say, I think your question was, what if there's information in a CSA that's not in the CDM model, right? So just like any information extraction system, you would have, not designed here, but theoretically, you would have a system that would go through the document and mark any places that haven't been extracted yet. And then it would be up to the human to review. And any type of system that's going through legal extraction like this would need a human in the middle anyway, right?
Thank you.
Mm-hmm.
Or we could add another AI that would write the...
That's happening. That's true. Okay, so here I'm using the Bedrock interface. I put in the initial prompt for the orchestration agent. And then I'm attaching the file that I looked at, that CSA. I'll skip over this. And then what this is doing is, on the right, what it's doing is it's going through, so the left is the orchestration agent. On the right are all the steps that are being done. So basically, it's the agents that are working on these specific clauses. And once the agents go through and finish extracting the information, it'll pass it back to the orchestration agent, and then you'll see that it produces a CDM JSON file. So here we've extracted a few terms. For the POC, we've only looked at 5 or 6 clauses, but this is to give the idea of the whole concept of using a multi-agent approach for going through legal documents. And I think this approach makes getting information out of legal documents, putting it into CDM standardized format, more accessible to more organizations rather than fine-tuning. Of course, the fine-tuning, you'll see in the next few presentations that there is something called FinGPT, which is fine-tuned. So if you use those models, it would work better. But with the multi-agent approach, you can also use different LLMs for different purposes. So if you're looking at cost factor, then you can use smaller models that are faster, more cost efficient for certain clauses that are easy to extract information from. And use for the orchestration agent, you can use the best of the breed. So that's it.
Thank you.
Sorry, any questions? Hi. Right now it is, but there's no, with these type of designs, it's created so you can replace any one of those areas. Yeah, that's a good question. So it's, for the design on the AWS itself, there's something called action groups and functions within the action groups. So action groups group together the related clauses. How much time do I have?
You can finish it.
Okay. Related clauses. As far as the number, what I say now might be obsolete 6 months from now. So, which is the same as when GPT first came out. It had such a small context window compared to today. But, with all our modularization, this might be a old story in 2 years when we don't have to worry about context windows. But for now, this design is very good for controlling management of the individual clauses because you don't want to go and update the entire code itself. This allows you to update a few clauses at a time.
Bona tarda. Okay, I just wanted to start in Catalan. So first of all, I want to somehow introduce first what Tradeheader does and what's the mission of Tradeheader, so we can understand why we build what I will present afterwards as a demo. So first of all, since Tradeheader started 13 years ago already, we found that open message standards are the way to go, right? And lately, we have seen how sharing critical business data has become the norm for the majority of firms. So basically, what we have always tried to do is to make those firms comfortable working with the standards, messaging standards, right? We base this on 3 main pillars. These are our 3 pillars, consulting, software development, and training. And they are all important, right? We all want to control what we do when we develop any application. So our realm of expertise does not only come from CDM. We have been involved in a lot of messaging standards over these years. And when Luca approached us and told us to build up something related to AI, we already had some things worked out for FPML and other messaging standards. But really, the CDM brings another level of complexity, right? CDM is complex. We all know that. It has a lot of information built in not only as data model, but also functionally. It allows you to represent a lot of business use cases across the life cycle, not only for trades, but also the life cycle of any financial instrument. So what we try to do first, is how can we make all participants on these projects to better understand the model. To achieve that, we observe that the technical representations, such as JSON, is not enough for business analysts to fully understand what the message is representing, right? So we want to make those messages more user-friendly. And in order to achieve that, we wanted to use LLM because of the way it can allow us to change the wording, use natural language, obviously, to explain this to non-technical people. When we work at Tradeheader on any project, we always have like a development guy or gal and the business analyst. Always work in tandem. So basically, what we did here is, how can we achieve this, this level of interpretation from the LLMs to be able to to fully understand the model? First of all, you'll see how our summarizer, this is the tool that we've built or will be presenting, the POC will be presenting. The CDM summarizer uses CDM-specific models because we needed that for prompt engineering. We've tested RAG, we've tested fine-tuning too, but in the end, what we found most useful, and yeah, at the beginning, was prompt engineering. So that's why we have these blue squares here, which are CDM-specific models. Then we have different agent-based or different LLMs to be able to extract detailed information for different parts of the instruments that we are working with, right? In this case, we wanted to work with trades, their events, and their product representation. And the product can be of any kind of asset class. So that's why we separated this in 3 different LLMs. The first one, the trade summarizer, which will allow you to inspect and define business definition, to give you business definitions for the different parameters related to the events, the trade event, and the trade life cycle. Then the product summarizer, which allows you to specifically go into the information for different asset classes, such as interest rates, commodities, credits, whatever. As you know, and Ian showed us before, the structure of these CDM messages depends on the product that you are representing. And finally, we have the additional information for all that extra information that we couldn't place in any of the other 2. So basically, as I said, this is a prompt engineered solution which uses CDM, Python implementation, and a third party, in this case is OpenAI, ChatGPT, to build up our models. What we have found during this year, almost a year and a half already, is that we needed to automate the deployment. We also needed to automate or somehow make the full stack to be usable for our internal staff. Obviously, if we are creators of the CDM, we need to understand the CDM and all its evolution. So that's something that we wanted to use internally, and it's good. Not completed yet, but it is working, at least for new people, newcomers that enter CDM and want to fully get what they are able to do with CDM. As a computational layer, we choose a serverless computational layer because obviously the irregularity of the calls and the processes of training. And as I said, we wanted the full stack, so we also created the API to be able to offer the solution to the users. I will show you now a small video of the application. It's loaded already, but yeah, I'll use this. So basically, the application, what it allows you is you can introduce a JSON representation of a CDM trade, and it will give you the ability to represent that information in a more business, for business analysts to better understand. As you can see, the different LLMs are generating this information and extracting it, and also the application, what it allows you is to go through the different representations of this trade. So obviously, a technical person can go into the JSON itself and see what it means, what this business term or concept means, right? And how it gets represented. There's also a score, an evaluation score, which was shown in the video before. This is our main topic right now, right? We wanted to be able to evaluate how the LLMs are working, how good the representations of these summaries are being generated. And that's something we still need to work on. We are using GEval right now, but we have some POCs of specific LLMs that will allow us to revise this information. Obviously, we can give feedback to the team so we can change and improve whatever it's needed. And yeah, I think that would be all. In this case, we are representing a swaption, an interest rate swaption. In terms of a structure, it can be more or less complicated if you don't understand them all fully, but at least you can find here specific data points that you can track back into the JSON. So yeah, as I said at the beginning, we started building this using RAG. As has been commented already, we couldn't get rid of the hallucination, not completely. Our main point here is we wanted to generate synthetic data. And that's something we couldn't achieve at the beginning. So what we step back a little bit and define ways to improve our LLMs and our prompt engineering, and also fine-tune these models. So basically, as improvements and as steps, we want to create a better summary. So we found some issues on the summaries and redundancies that we need to solve. The additional information is a block that needs to be rethought again. But what we are trying to achieve basically with these next steps is increase the coverage of the product coverage of the CDM. Right now, we are, as you know, as I said before, we are making specific CDM models to extract information, and those models somehow drive how we prompt engineer these LLMs. We want to get rid of that to make more general approaches into the CDM representation, business representation. In the end, that's our main focus by the end of this project, is to have a foundational model that can fully understand and interpret the CDM. So yeah, that should be all. Is there any questions?
Hi, my name is Felix Tian. I am a research assistant working at Columbia University for Professor Yang Liu, which very unfortunately cannot be here today, so I'll be talking for him about FinGPT, specifically FinGPT with CDM. So FinGPT, maybe you have heard it, maybe you have not, but at the current moment, it is an extension, a web extension that's capable of scraping the websites, but for CDM, we have developed a brand new agent, basically, specifically for CDMs. This project was originally developed so it can fully understand CDM and DRR to automate the process of generating a CDM regulation and DRR rule pair. So this is the ultimate goal with the FinGPT agent integrated with CDM. But unfortunately, within 2 weeks, we were only able to get the first half working. So at least we get the agent to fully understand CDM, which I will show very quickly. And then, yeah, our vision is to make anyone professional at finance. How? Well, by capturing the complexity of any websites This can be Yahoo Finance, this can be CDM, it can be EMIR. So as long as the agent will be able to capture a website's complexity, then the agent will be able to very accurately represent whatever information is on that website, which makes a user's browsing experience much more simpler and much more accurate. And that is our vision. So specifically for CDMs, for automatic rule pair generation, here is a very simple diagram of how this thing may work. So the user enters a prompt to the agent, which the agent fetches, uses RAG, so retrieval-augmented generation, to fetches documents from the CDM documents and from the DR documents to make sure it has the correct context for the rules, which are all fed into the context window, generating an enriched prompt, including the user's prompt and all the context available, which is then fed into an LLM, which generates the responses. And hopefully this response will be the rule, the DR rule that one wants. So one major advantage of this pipeline is currently for generating this rule pair, everything has to be done manually. And CDM is a new project, so it's on constant update. So the cost and time spent of managing this constant updating by keeping the DR rules up with the CDM is very costly. So that's why we need or we want a way to automate this process. So in the future, we want something more like this. This is still a single agent-based solution. So it's the simplest solution we have. Obviously, there is a multi-agent solution, but we will be not talking about it here. So basically, we want any kind of data sets with the user's prompt to be fed into a dynamic vector database, which this entire agent is built around this database such that the agent has information of both the website the user cares about and the user itself. So this database does not only capture what the website is talking about, but also captures, hopefully, what the user wants. And the rest is mostly the same as the previous diagram, except the fine-tuning part, which obviously we want a model that's fine-tuned specifically for CDM or for EMIR or for whatever websites you're using it on. And then finally, it generates a response. The response is fed back to the dynamic vector database to enhance future interactions. And here are some benchmarks, at least, for the current large language models. So we have benchmarked the CDM data sets for a total of 99 sets with the details listed here. The matrix is rogue, which is a matrix ranging between 1 and 0 that tells you directly how much the generated answer matches to the correct answer. And then as you can see in the next second slides that most of the models do pretty poorly without context given. For example, our beloved GPT-4o with 0 shot only achieves an average accuracy about 14%, which is far, far from usable. So from these models, from this graph, we can draw a simple conclusion that yes, it is not possible to use it with CDM just by the models themselves. We need some way, shape, or form to let the models learn, like I said, to let the models capture the complexity of CDMs. And how do you do that? Well, there are multiple approaches. The simplest way is via RAG, which I will show very quickly. And yeah, let me just let the video roll for now. So we'll be doing a 3-part demo. This demo will have 3 parts. The first part is parsing CDM. So this agent is currently reading a localized RAG. So what I've done is I've downloaded the CDM repository, embed the entire repository, stored all the embeddings into a local FAISS vector database, and then let the agent read off it. So the agent can have basically 100% accurate answers regarding any CDM information, from high-level summarizations to extremely detailed, highly specific questions, as I'll demonstrate here. List all the functions inside date math, including CDM, which should have a total of 14 functions. And then as you can see here, the chunk 8, it's very quick. Wait, let me scroll back a bit. Sorry. So as you can see, the chunk here is the number of chunk, oh my God. So chunk 8, chunk 7, so the chunk is basically the chunk of text the agent is fetching from this dynamic database. Well, currently it's not dynamic, from this vector database that the agent uses to answer very specific CDM questions which generic LLMs will be impossible to answer. So, and then here, as you can see, it should give all 14 functions included inside the date math function of CDM with an explanation. Well, I'm using 2 models here, so the left one is more advanced, the right one is more primitive. Yep, so, oh, it's fine, thank you. So yeah, it starts with capturing the CDM itself before you can do any generation about it. And then the last will be, oh, okay. I'll just speed through. And this last one is a simple use case about security lending. So it just proves that the agent cannot just, pull information from the CDM, but it actually knows what it's supposed to be doing when an actual use case shows up, which hopefully we can use this as a building block toward generating the automated DRR rule pairs. And yeah, I'll just skip all of that. So that's, yeah, the rest of this video is basically about this. So yeah, that's everything. Thank you.
Thank you.
So regarding the prompting, right, there are 0 shot and few shots. So the reason why Ian was so successful with his work and POC that he showed, because there are few shots that we put together before, right? So you can actually go and use any prompts. It's not prompt defined, right? We didn't fine tune the prompt that Ian was using. He was free to use whatever he wanted. The few shots that we put together to make sure there is no hallucination and we use the right information in the right order, that's what made this a successful POC. Your point feedback is great, but not in 2 weeks. We actually, human is always in the loop in terms of being able to provide the feedback, right?
I'm just kidding. He asked if you guys have suggestions.
Yeah, no.
I'm not judging everyone here.
No.
You're doing a fantastic job. I know how hard it is to implement everything. No judgment, nothing. I know that actually getting from the idea to POC that shows work is a hard job. It's not easy. Everybody thinks, oh, this is a POC. Oh, this is really good. It's so much work. I totally understand.
No, we didn't take it as a negative. I just wanted to explain that there are a few shots that was there to make sure that everything works well.